The conclusion of Expedition 42 means it's time to talk about Expedition 4142 Science with lead increment scientist Dr. Vic Cooley. In almost 6 months for this crew, plus the one before it, how many experiments did the space station crews take part in?
On increment 4142, there were 258 investigations officially logged, and that ranges all the way from the very simple 4-inch cube type of experiments that can be plugged into a USB port for power and data, all the way up to the extremely complex and massive alpha magnetic spectrometer.
There was a group of biology experiments that go under the umbrella designation of Gene Lab. Remind me of what that was and how that went.
Well, it went well. We've had 2 experiments so far that will contribute data to the Gene Lab. The Gene Lab is basically a protein data bank. We've had a protein data bank concept now for about 20 years, where biologists from around the world, as they discover gene sequences in model organisms, primarily like fruit flies, fish, and worms, and rodents, will record those gene sequences, those protein sequences, and genes and proteins are kind of synonymous here because genes encode proteins. And now the Gene Lab will be a protein data bank that's open to the public, and in it will be data from organisms and how their genes change in 0G. So this can be from genetic mutations that are passed on from one generation to another, or epigenetic gene mutations that happen outside of the microRNA transcoding of that genetic material into proteins.
And there'll be other experiments that will contribute to that?
Gene Lab will be an ongoing for the foreseeable future, 10s, 20 types of years, where we will constantly add to this database, this protein data bank, if you will, now of organisms that have either been born or hatched in space or flown to space after they've been born, to see how their genetic material changes as their bodies adapt to weightlessness.
A couple of other things that happened during this time that I wanted to get you to touch on. One of them is a photography, not an experiment with photography. It's involved with crews not taking pictures of the Earth, but pictures of the Moon. What is this moon imagery experiment?
Okay, so this is all about navigation and a backup system for NASA's next manned vehicle, known as the Orion capsule, which would go to Mars, perhaps back to the Moon, and to an asteroid.
Mm-hmm.
So there's a primary navigation system, but if it should fail, the crew members and the vehicle itself would have to resort to techniques that the ancient mariners used, just navigation by stars and the moon. So the moon imagery requirements that we just did over this past weekend, Terry Virts photographed the moon from the node 2 zenith window that's in the hatch for that on that node port, but he also photographed the moon from the cupola. The primary objective was to get the imagery from the node because it had the most direct shot. It was on the zenith side, so it was facing away from Earth rather than down towards the Earth. Remember, we're only 250 miles so high, so the moon is still very far away. So this purpose was to see how well that imagery, and it's necessary to do this from low Earth orbit to avoid atmospheric distortion that we would get if we tried to calibrate this. It's really a star sensor that would be used as this backup navigation system, but it has to be calibrated once it's in space, and what you calibrate it with would be the moon, because it's of a known brightness, and obviously it's very big. It was made to fill up 60 to 70 pixels in diameter of the moonshot. So it is still quite a bit small in this picture, but it is about 60 to 70 pixels across, and that's enough for an accurate determination so that the sensor, which would then look at stars, could very accurately tell how bright each of those stars is.
Using this as a reference.
Using this as a reference. And it's the brightness of the stars in addition to the star pattern. It's really the brightness that gives you certainty that you've identified your location, and more importantly, which way is it back to Earth.
Also, in the last couple of weeks, we saw more than a dozen small satellites deployed from the space station. Tell me about this CubeSats program and how well that's working.
It's working extremely well. There's so much demand for these CubeSat launches that we simply can't keep up with it at this point. So we're expanding our capability to do that. Right now, we can launch CubeSats once per month through the Japanese airlock, and there you see 2 satellites just deployed from one of the silos. There are 16 silos in that particular case. So over the past 10 days, we deployed 16 satellites total. 12 of them were from a company called Planet Doves. They're called DoveSats, and as you see how small they are, those cases, they were 4-inch by 4-inch by 12 inches long. So each of those satellites, there are 28 of them that will make up a flock that will cover at least the Earth through plus and minus 58 degrees latitude, and can provide near real-time imagery, whereas the current capability from very expensive satellite services that provide imagery, it takes about 2 or 3 weeks to make a request and actually get the product, because there's only one satellite in that case, maybe 2, and they don't fly over that part of the Earth that frequently. But with a big flock of 28 of these small, very inexpensive satellites, you can get a 24-hour turnaround. That's the goal of the company called Planet Doves, is to make this type of imagery available. Its resolution is about 10 to 15 feet per pixel.
Right.
So you can identify, for example, a tree canopy.
And CubeSats are launching satellites for private companies and student groups and lots of different organizations.
Yes, as I mentioned, we launched 16. 12 of those were for Planet Doves. The other 4 one was for Massachusetts Institute of Technology. There were some companies that launched another satellite to test the Global Star navigation system, which is different from GPS and TDRS, but it's another space network. It was testing to see if it could use that network to do command and data transfer. One of the other very interesting experiments attempts to return samples from the space station in as little as 18 hours. So we know that we just saw in the previous footage of the Soyuz that just returned how scorched the surface of that capsule was, because it returned through the Earth's atmosphere in a matter of about 4 hours. So you don't want to come in that quick, but you want to come in as quick as possible, because you're trying to return biological samples, and they're probably passively refrigerated. So, getting them back within 18 to 24 hours is kind of the goal, and that's where TechEdSat is headed. That was a similarly sized satellite as the ones we saw. It had a deployable aero brake, which is, you can think of it as a parachute, but when you're 250 miles up, there's not that much atmosphere to grab a hold of and produce drag. But even a small aero brake, which kind of looks like a parachute, does produce enough drag to allow it to re-enter, not quite as quickly as the Soyuz, but over an 18 to 24-hour period to return biological samples.
It'll be interesting to see how all of these things come out. Vic, thanks very much for sharing
Pat.
the information. Dr. Vic Cooley is the lead increment scientist for the International Space Station's Expedition 41 and 42.